Here is a question that we're going to address, and this question here looks at seawater, and this water here has something that is quite common, and this here is based on the following information. This here is what is given, and here on the other side is what we want to get out of it. And so how is this going to play out? We need to first understand what it means when we look at percent composition, and this is going to be biomass for sodium chloride in this case in water. And this here states that it is given to be around 3.6% of sodium chloride biomass, and this mass is also applicable here for what we want out of it. Now the question says that we need to get around 80 grams of sodium chloride, but now the question here is, what is the volume that is going to be needed for we to extract 80 grams of this particular sodium chloride in seawater? Now the seawater that is given in terms of the density is around what? It's around, let's say, 1.04, and we have the units to be in grams per milliliter. And so once we have all this information, we need to be able to determine what the volume of the seawater that is needed in order for we to get 80 grams of sodium chloride. And we are going to begin with the first step. The first step here is that since we have the percent biomass, which is 3.6 of sodium chloride in, let's say in this case biomass grams, in 100 grams of seawater, we need to have a ratio between, in this case, sodium chloride and seawater, and this here has to be, in this case, equivalent to what is wanted. And in this case here we have sodium chloride that we want to be 80 grams of sodium chloride. We have to keep the sodium chloride as a numerator, as well as what we have right here for the numerator, over how much grams we need of the sea water. And so once we have this set up, we can now do cross multiplication in order for we to determine what the grams of seawater is. And in this case here, we'll multiply 100 by what? Our 80, and we're going to divide our answer by what? 3.6. And so take note that our answer here is going to be in grams of seawater, and that is what we are trying to find, the mass of sea water. And so once we get into a calculator, we have our 100 times our 80. Of course, this is straightforward, 8,000 divided by 3.6, and this here is equal to this number. When you change it to decimal, we have a repeating decimal to be around 2,222.2, which is repeating grams of sea water. But here the question says the volume, and we know that the density of seawater here, not only for the given and the wanted, is the same, and it is given to be 1.04. That means that we need to use our density formula, which is the mass divided by the volume, since we know that our mass is determined here to be this value, and we have our density here to be this value over here. We need to determine what the volume is, and we know that this here is same thing as in terms of determining the volume to be the mass divided by the density. Therefore our mass, which is 2,222.2, we just stop there, grams, is going to be divided by the density, which is 1.04 grams per milliliter. And so by having this on your calculator, this is our answer divided by 1.04. This here is equal to the volume to be in milliliters to be 2,136.75. We're going to stop here, milliliters of what? the seawater that will be able to produce around 80 grams of sodium chloride. So I hope you found this really informative in terms of using percent composition as a conversion factor here to determine how much we want based on what is given. Hope you found this really informative. See you on the next one. Stay smart as always and keep on practicing.